Hello friends, welcome to Prismatics online class. In today's class, we are going to look at how to use inverse of matrices to solve some simultaneous linear equations problems. Looking at the question on the board, the question says solve the following equation by using matrices inversion. So we are going to use what inverse method to solve this kind of problem. And what are we looking for? We are looking for x, y, z. And before doing that, you need to write the first step, write the augmented matrices. Second step is this: after writing the augmented matrices, you find the A determinant, the determinant of the matrices. After then, you now find what we call the cofactors. After finding cofactors, you transpose the cofactor. And when you get the transposition of the cofactor, we call it adjoint. And the A inverse is defined as what? Adjoint over the adjoint over what? A determinant. Adjoint over the determinant of the given matrices. Before now, you multiply out to get your what? X, Y, Z. And that is how to do it. Let's proceed. Thanks. Solution. Write down the augmented matrices, which is what? 1, 2, minus 1, 3, minus 1, 2. 2, minus 2, 3. This is this. Into what? What are we looking for? We are looking for X, Y, Z. Row 1, row 2, row 3, X, Y, Z. And is equal to what? 3, 1, 2. Okay. And that is thing. So what do we look for? We look for a determinant. The determinant of the matrices. Assign number A equal to this. And remember that the first one is plus, second one minus, third one plus. So what do we do now? We have to reduce this into 2 by 2 matrices, which is 1, 1, 1 into what? Minus 2 into minus plus will give you minus 1 into. Now what do we have? Pick something and cover this place, the first row, and be covering it. We have this in as this one cover, we have this one as minus 1, 2, minus 2, 3. Close it. Close this one. What do we have? 2, 3, 2, 3, 2, 2, 3. Close this one. What do we have? 3 minus 1, 2 minus 2. So we are done. We have this as our A determinant is equal to 1. 3 times this will give us minus 3. Minus 2 times this, which is minus 4. Minus 4. Minus is what? Plus. Close it. Minus 2 into what? 9 minus what? 4. Close it. Minus 1 into what? Minus 6. Minus 1. We turn this into what? Plus. Now our A determinant is equal to 1 into what? This to this will give us 1. Close it. Minus 2 into what? 5. Close it. Minus 1 into what? Minus what? 4. Close it. Our A determinant is equal to what? 1 minus 10 plus 4. 1 minus 10 plus 4. So when we add this, it means that our A determinant is equal to minus 10 plus what? 5. Which our A determinant is equal to what? Minus 5. So what do we get? Our A determinant is equal to what? Minus 5. So our A determinant is equal to minus 5. Okay. When you are done, you have to come to here and write another one. This one. This is what we call A11, A12, A13, A21, A22, A23, A31, A32, A33. So we are going to equate this. This is equivalent to what? The given matrices, which is what? 1, 2, minus 1, 3 minus 1, 2, 2 minus 2, 3. Close it. So what are we looking for? We assign numbers. Ability to assign binary operation to this thing is called cofactor because we want to get the cofactor. All this in one after the other is called minor element. But when you assign negative or when you assign positive number or negative number to those minor elements, we call it what? Cofactors. So which is the first one is what? Plus. Second one minus. Plus. Minus. Plus. Minus. Plus. Minus. Plus. That is how to do it. So now let's go. 1. Now let's look for A111. Our A11 is equal to, what does it have? We have it, reduce it 2 by 2. Pick your this thing because we are the first column. Pick it from this place, they are the same thing. Pick it. What do we have? Close this one. We have minus 1 minus 2. Minus 1 minus 2. 2, 3. So our A11 is equal to this time this which is minus 3 minus this time this which will turn to plus 4. Now our A11 is equal to what? Minus is equal to what? 1. And that is it. For A12, our A12 is equal to minus, reduce this into because it has minus. Minus reduce this. So are we going to the column 2? What do we have? We have 3, 2, 2, 3. 3, 2, 2, 3. So our A12 is equal to minus into what? 9 minus what? 4. Close it. Our A12 is equal to, this is minus 5. So for A13, our A13 has plus, which is A13 equals to, do this. Close this one. We have 3, 1, 3 minus 1, 2 minus 2. 3, 2, minus 1, minus 2. Now our A13 is equal to, what do we have? What do we have? 2 times this, which is minus 6, minus 2 times minus this, we turn this into what? Plus. So which we have this, that A13 is equal to minus 4. We close it. For A21, it has minus. A21 is equal to minus into this. Remember, you are in a second row. Bring it. We are done with first row. Close the second row. So now what do we have? Close this. We have now 2 up, minus 2 down, minus 1 up, minus 1 up, what? 3 down. So now what do we have? We have that A21 is equal to minus into, this time this is 6. 6 minus 2 times this, which is 1 minus 2. 2 times this is minus 2 times minus 1 is 2. So we have A21 is equal to minus into what? 4, which is A21 is equal to minus 4. Close it. For A22 is equal to, it has plus, which is this to this. Close this in. Now what do we have? 1 minus 1, 1 minus 1, 3, 2, 3, 2, 3. Now A22 equals to 1 times this, which is 3. 3 minus 2 times this, which will give us minus, minus will give us plus. So A22 is equal to 5. Now for A33, for A23, which is minus into this, reduce, put this, you have 1, 2, 1, 2, 2 minus 2. So what do we have? A23 equals to minus into, this is minus 2, minus 2 minus, this is 2 times this, minus 2 minus 2 times 1, which is what? 4. Close it. We have A23 equal to minus into what? Minus minus will give us minus 6. Finally, our A2 is equal to minus is equal to minus times minus will give us plus, which will give us equal to minus plus 6. Now we go for A3 1. Our A31, you change the rule with the last this thing. What do we have? A31 is equal to what? No, this is plus. Okay, close this. We have 2 minus 1 minus 1 2. 2 minus 1 minus 1 2. And what do we have? 2 times this. We have this in as A31 equals to what? 4 minus what? 4 minus what? 1. A31 equals to what? This is 2 times 2, 4 minus 2 times 2 what? 4 minus what? 1 times 1, which is we have this in as what? Alright. I hope you get it. This is for this one we have 2 and 1 minus 2 and minus 1 minus 1 and 2. Okay, so which is now 2 times 2, which is 4 minus 1 times minus, which is also our distance is 3. Now let's go. We have another one for A32. Our A32 equal to minus into what do we have? Close this. We have 1 3 1 3. We are closing this 1 3 1 2 minus 1 2. So we have this now A132 A32 equals to minus into 2 times this, which is 2, minus 3 times this, which is minus give us what? 3 minus plus, which are A32 is equal to what? Minus 5. Close it. For A33 equal to what? We close this. Now what do we have? We have 1 2 3 minus 1. So what do we have? This will be now A3 equal to this time this, which is minus 1 minus this time this, which is what? Minus 6. A33 is equal to minus 7. And that is how to get this. That is how to get this. So that first A31, if you close this, you are going to have 2 minus 1, 2 minus 1, minus 1, minus 1, 2. So this time this will give us 4. 4 minus times minus 1. So that is the reason why we get 3. Okay, now we are done. So you remove this. So you have succeeded in getting new numbers that will replace this thing. So we are going to replace them. Our A11 from the beginning, our A11, which is it, is what? 1. Have it as 1. A12, we have it as minus 5. A13 minus 4. A21 minus 4. A22 5. A32 A32 A what? 32 6. A31 3. A32 minus 5. A33 minus 7. So now what do we have? We have succeeded in getting this. So are you done with this? So I need to wipe it up so that we continue. Okay, thank you. Now from this in now, we have succeeded in getting this. So now let's look at inverse method. So we are through, and we have gotten our uh, um, we have gotten our trans cofactor. Our cofactor C is equal to 1 minus 5 minus 4 minus 4 5 6 3 minus 5 minus 7. This is what we call cofactor. So now when you get adjoint, adjoint is what? Adjoint is what? Transposition of what? Cofactor. So let's transpose this. C transpose is equal to this one, 1, I'll change column to row, 1 minus 4, 3. This one, minus 5, 5, minus 5. This one, minus 4, 6, minus 7. So we call this a what? Cofactor. We call it what? Adjoint, transposition of what? Cofactor. And what is the formula for inverse? Because we want to get inverse. Inverse is equal to minus A inverse is equal to adjoint A or C transpose anyone all over what? A determinant. And that is what we are going to get. We are going to get our what? Inverse right now. So from this place, our A inverse, always remember that our A inverse, our A determinant is minus 5. Minus what? 5. So what do we have? We have that our A inverse here is equal to this adjoint, each one divided by minus 5, which is 1 divided by minus 5 will give me minus 1 over 5. And for minus 4 divided by minus 5 will give me what? 4 over 5. 3 divided by minus 5 will give me minus 3 over 5. Second one, minus 5 divided by minus 5 will give me 1. 5 divided by minus 5 will give me minus 1. 5 divided by minus 5. 5 divided by minus 5 will give me 1. What do we have? 4 divided by minus 5 will give me 4 over 5. 6 divided by minus 5 will give me minus 6 over 5. 7 divided by minus 5 will give me 7 over 5. And this is what we call what? A inverse. A inverse. So that is our A inverse. Okay, but we are not looking for A inverse. We want to get the value of X, Y, Z. We want to get the value of what? S, Y, Z. Okay, the value of S, Y, Z from here, there is a formula that says that a relationship that says that AX is equal to what? B. Now what is our A? So our A is this. Our X, divide both sides by what? Coefficient of X, which means our B is all over what? A, which is the same thing as saying what? A inverse B. So this one is B. So we are going to look for what? A inverse B. So meaning what? Minus 1 over 5, 4 over 5, minus 3 over 5, 1 minus 1, 1, 4 over 5, minus 6 over 5, 7 over 5. Multiply by what? Multiply by what? B. Our B is what? 3, 1, what? 2. Close it. Is it equal to what? What are we looking for? X, Y, Z. Close it. So this multiplication, let's do it here. Let's do the multiplication here. Okay. Now, minus 1 over 5 multiply by 3 over 1 plus 4 over 5 multiply by 1 over 1 plus minus 3 over 5 multiply by what? 2 over 1. Okay, this one 1 times what? 3 plus minus 1 times 1 plus 1 times what 2. Close it. Okay. Finally, we have 4 over 5 multiplied by what? 3 over 1 plus minus 6 over 5 multiplied by what? 1 over 1 plus 7 over 5 multiplied by what? 2 over 1. Close it. Close it. What do we have? This into this into this. And what are we looking for? We are looking for what? X, Y, Z. And that is what we are looking for. Okay, let's go. This will give us 3 times Z, which is minus 3 over 5 plus 4 over 5 minus what? Minus 6 over what? 5. What do we have here? 3 minus plus minus 1 plus 2. What do we have here? 12 over 5 minus plus minus 6 over 5 plus what? 14 over 5 all into this. Is it equal to what? X, Y, Z. And that is what we are looking for. Okay. In solving this, finally, what do we have? Finally, we have LCM of all this is what? 5. So, which is now minus 3 plus 4 minus 6. Here is what? 3 to this will give us minus 3 to minus 1 will give us what? 2. 2 plus 2, which is what? 4. What do we have here? We have LCM as what? 5. So, which is 12 minus 6 plus 14. Close it. Is it equal to X, Y, Z, which we are looking for? Okay. Listen, 3 to this one will give us 1. 1 minus 6 will give us minus 5 over 5. This one 4. 12 to this, 12 minus which is 6. 6. 6 plus 14 will give us 20 over 5. Is it equal to this? Is it equal to X, Y, Z, which is this? Now let's go. This will cancel. Okay, this will cancel. We have 4 here. This one will cancel. Finally, what we have minus 1, 4, and what? 4. Is it equal to what? X, Y, Z. So that is it. So finally, what do we have? Finally, we have hence X equal to minus 1, Y equal to 4, and Z equal to what? 4. If you want to check when S is what? Minus 1 plus 2 into what? 4. Close it. Minus what? Z, which is 4. Is it equal to 3? Let's look at it. Minus 1 plus what? 8 minus what? 4. Let's go. So this minus will give us minus what? 5 plus 8. Is it equal to 3? Is it equal to 3? Which this minus 5 plus 8 plus 8. This is minus 1 minus 4 will give us minus 5 plus what? 8. Is it equal to 8? This to this will give us what? 3 is equal to what? 3. And that is the answer. Proof. So the X equals to minus 1 and X equals to minus 1, Y equals to 4, and Z equals to what? 4 are the solution to this equation. Thanks and God bless you. Remember to subscribe to my YouTube channel, Matrices Online Class. Bye.